Okay, so let me open the model which we have prepared in our last class. So this is the problem. This is the model which we started. For example, the distance between A to B is 1000 and B to C is 7000. C to D is 5500 and D to E is again 5500 and same on the other side. And from 1 to 2 the distance is 6000 millimeter. 2 to 3 it is 4000. It is 6000 and then it is 4500 and then again 6000. Okay, so and the number of stories we decided for. The first story is 4000, next is 8000, 11500 and 15000. So we were working on the first. I told you we will work on the one floor first, and we were discussing about how to define materials. So in our last class I told you how to edit grid data and how to define the materials. For example, we have defined two materials. One is FC20 and one is FC30 megapascal. Okay, so these are the material properties which we have decided. Important things are these values: E, U, unit weight, and specified strength. If you are going to use lightweight concrete, you can click it over here. In the latest versions of SAP, there is one option which is known as non-linear or inelastic behavior of materials. In that case, you can provide the full stress strain curve of concrete. Okay. Okay, so now you have added the materials. Now next we will go to the section properties and we will add frame sections. So when we talk about the frame sections, we have how many types of sections in our class problem? We have how many types of beams? Only one type of beam? I mean, we have decided only the one size of the beam. Okay, and we have decided two sizes of the column. About the size of column, actually at the beginning you can assume any size. You can assume 450 by 450, you can assume 600 by 600. If you are a beginner of concrete design, you can select any tile size, and I would recommend you to do it because it will help you to learn more about the software. Because when you will use a bigger size for a small building, what will happen? But how you will come to know that you have selected a bigger size?
By trial, every time you place it is stable.
If you select a bigger size for column, you will get the minimum reinforcement always. For example, if you get the size of column 600 by 600, and how much is the minimum reinforcement for a column? Yes, it was also question in your quiz. It was the question in your quiz, 0.01. So what will be the reinforcement? 3600 millimeter square. If your reinforcement is always 3600 millimeter square, it means that it is the minimum reinforcement. You can also see the reinforcement ratio. So what you will do, you will reduce the column size like 450 by 450. Again you are getting raw minimum, it means you can further reduce the column size until and unless you are getting some reinforcement which is higher than raw minimum. If your reinforcement ratio is more than 8% in the column, it will show overstress
I need to increase the.
and the color will become red. For example, the actual size of the column you need 600 by 600, but you have provided 300 by 300 because you don't know. So what will happen? Your column will become OS. It will show a red color. It means that you have to increase the column size. So as we go further, I will explain you. Please remember all these things. What I am telling you, it is not just a word. These are the guidelines to model your structure in the computer. Okay? Do you have any question? Now, for example, one question could be in your mind that why we need the size? Why we need the size? Actually, this software is based upon finite element method of modeling. Okay? And for finite element method of modeling, you must provide the initial size of the members. Now, what finite element method gives? Finite element method gives you the displacement and rotation. And from these displacement and rotation, you get the forces. Again, many of you may think that first we apply stress and then we get strain. Is it true? For example, we think that when we apply load, and then what will happen? It will give stress, and due to stress there is strain. This is what we think. But when we actually, the thing is that when we apply strain and then stress is developed. For example, when there is a rubber, if you push this rubber, then it will generate a force, resistive force. If you do not pull it, it will not develop the resistive force. Same with the spring. So it means you give displacement, you give strain, and in return you get some force. You understand?
Yes.
So this SEM, it gives you the displacement and rotations, and from those displacement and rotations you get the forces. If you know the stress, you can convert the stress into force, and if you know the force, you can calculate the reactions. Okay? Maybe I think I'm talking little bit on the outer boundary of your mind. You understand? Maybe I'm talking something at the outer boundary of your learning, but I have to. I have no other choice, because this is the beginning of structural analysis, what I'm telling you. This is the beginning of structural analysis. I wish that I could teach you a course on this, but we always, everyone is short of time. Not only me, you also. Okay. So that's why we have to give the frame section. Please see how to give a frame size. Now we have three options. One is import new property, add new property, and add copy of property. For example, import new property. If you have a table of materials, you can, for example, if I click import new property, I have the standard sizes. For example, steel, concrete, aluminium. For steel, if I click I section, so it will ask me, please tell the library, where is the library from where you want to import these sections. You must have the library of the sections which you have defined. If you have not defined any library, then you can go to the add new property. The same thing, import new property and add new property. Now over here you can add some section. For example, now If you are designing a concrete building, you can select any shape for the steel. For example, like I shape. Here you can give the total like web thickness, top flange thickness, outside height, top flange width, and you can give the name. But as we are dealing with the concrete, so we have to select concrete. Please see, it is very important. Now, what type of section we are going to provide for beam? Rectangular. Okay, so now please give the size. You can say beam 600 by 300, and then you have to select the material for this beam. And in this bar, all the defined materials will be appearing. You can select FC20, and then you have to give here the depth of beam 600. Please see, this is 2 and this is 3. Remember this now, or take a snapshot in your mind of this picture. 2 and 3. What is 2? What is 3? Now, because we are going to play with the 2 axes. One is X, Y, Z axis, and one is 1, 2, 3 axis. Now, for every cross section, 2 and 3 are the centroid axis, and 1 is the longitudinal axis. One is running along the length of the member, and 2 and 3 are the cross section. For example, if I want to see the bending moment for this beam about 2, it means if I apply load here, so it will produce bending moment about 2.
Yes. No, about 3.
About 3. If I apply load on 2, beam will bend like this.
Yes.
And if I apply load like this, so for lateral loads, you can see the bending moment about M2. Remember this, because if you do not understand this, when you will go to see the forces, it will not tell that this is Mx, My. It will say M11, M22, M12, V11, V22, like this. So what will be V22? It will be this or this. And what will be V12? Okay, tell me what would be M11? M11. 1 is like this.
Yes.
So it is the torque. Yes. So remember this. So axial force P11, force along 1 in the direction of 1. It is axial force. And shear B23 and B32, they are equal. Okay. 600 and 300. Now again you will click here concrete reinforcement, and you will see this type of window. Now what type of member is this? It is beam or column? Now please see M3 design only. Now again M3. M2 M3 design. It means it is biaxial column. Now M3 only. I'll show you. Now what is 3? So M3 means the moment about like this. Load is acting along 2, so it will produce moment about 3. But for biaxial, load will act like this and like this, as I have explained you in the design of biaxial column.
Yes.
There are 3. One is the axial load, one is load like this, X and Y. So if this is the load, it will produce M2.
Yes.
And if this is the load, it will produce M3. Okay. So for beam it is saying it will design only M3. For the, if I say for the gravity, for vertical loading. Okay, now again see this. M2, M3, it means biaxial bending. Beam only about 3. Now what is top and bottom cover? Longitudinal rebar center. It is the center to bottom. It is just like D. How to calculate D? D 60 or 75. So it is that 60. It is saying concrete cover to the center of bar. Concrete cover to the center of bar. No, that is clear cover. Clear cover is 40, but up to the center of rebar we take either 60 or 75. For this case, I told you we take 75. Okay, now the rebar material. What type of rebar material you are going to use? Grade of rebar. 420 or 300. This 60 grade is basically 420. Okay. Now if you have, now let me make it okay. Now let me see, either we have defined, for example, now if you want to define material. Now these two grade 60. Now please remember, GR means grade. Grade 60 and FY 60. A, what is A? It is ASTM 615 and A992. These are the material specifications. FY 550, it means that the whole section is made up of steel. Okay, and this grade 60 means you are going to use rebar. Don't select this. This is for the whole steel section. Okay, but if you want to make some new material, like add new quick material, you can select from here. For example, now this is grade 60, grade 50, and if you could find the grade 40, okay, but if you could not find the grade 40, then what you can do? You can add it. For example, here we cannot find the grade 40. Grade 40 is 300 megapascal. And this is 836. Okay, let's use the grade 60 and add copy of material. We say grade 40. It is material type is rebar. Everything is same. What we are going to do now, see here, it is telling for 13 megapascal. We can make it 300. And again, this value for ultimate stress is a breaking stress is around, you can say, for this it is around 450, and expected yield stress, I mean it would be slightly more than this, maybe you can say 320, and expected FU it will be slightly more than this, you can say 475. They are actually, these two values FY and FU, they are the safe values, but the actual values would be higher. You understand? Okay. Grade 40, it is over here. It is not 300, it is 420. Okay. Now again go back. Frame section. This is your frame section you have defined. Modify show property and concrete reinforcement. Grade 40. Now confinement bar, these are basically shear steel. Stirrups. Okay. Okay. Now should I go next? Now, for example, if you want to add some more sections, you can add. Now, please see, there is no steel here. It means that it will design it. It will design it. Okay, now for example, if you want to add one more section, you can just click the same one, add copy of property. You can give the name like beam 450 by 300. All the things will be the same. You can change 450 and the other things will be same. Okay. For example, now you want to add a column. You can go to add new property, rectangular, column, C 450 by 450, material 30. For column we decided we will use 30 megapascal. Tell here 450. 450 concrete reinforcement, it is column. Now what type of column? Circular or rectangular? Rectangular. So there will be ties. Now here you can see clear cover. It is not clear cover 40 in all directions. Okay. Now number of bars on one face 3. For example, now please see here, this is the face along 3 and this is the face along this is the face along 2 and this is the face along 3. Okay, so these are the 3 bars in both faces. You can change them. For example, if you want 4 you are not going to design it. But for the calculation purpose you have to give it. Now please see these reinforcement sizes. Number 10, number 11, number 14, number 18. This number, when it is like this number, it means the sizes are in US. Sizes are in US. No one is writing. I think everyone is very intelligent. He will remember this. Okay. Okay. Anyhow, number 19 means US. It means 9/8 of an inch. Okay, 9/8 of an inch. If it is number 8, it means 1 inch. If it is number 4, it means half inch. So if it is number 9, it means 9/8. So it is now. So number 8 is basically number 25. Now this 25 m is the size in SI. Okay. What we have used like number 19. Number 19 is basically US size but in millimeter units. Okay. Okay. Let's select number 25. And there are many more sizes like this.
Why there is no 19?
For example, in this is number 4 is basically number 13. Anyone have formula sheet? So now if you see US designation number, SI designation number, in the first table there are 2 designations. Number 1 is SI designation and number 2 is US designation. Now please see, if the US designation is number 4, it is number 13. Can you see? Please see the formula sheet. So number 4 is basically US designation, which means number 13. So if you want to use number 25, it is number 8. Okay? If you want to use number 22, it is number 7. Anyhow, let's use number And for the confinement bar is tie. Number 4 is number 13 and number 3 is 10. And this is a spacing of tie. You can give it like 300. Okay, we can keep it like this. And we make sure that we are going to design the reinforcement. If you click here, it will check the capacity that either this column is safe or not. But as we are going to design it, so we must have to check this box. Okay? And make sure it is gauge 60 over here. Okay? Anything clear? Okay. Now you can see 4 bars in both directions. Now section properties. If you click over here, it will tell you all the things like this is the area, this is the moment of inertia about 3, I3, like Ix. This is the moment I2, 3 is X, and now please see 3 is X for your sections and 2 is Y. It means M3 is basically Ix, this is Ix, this is Iy. This is shear area. Maybe you are not familiar with these things, but you are familiar with this radius of gyration. Radius of gyration. I talked about this many times. This is the R. Okay, and this is C, torsional constant C. Anyhow, let's go back. You cannot change. Actually, if you change the size, then it will automatically change. These are the section properties, but they are set modified. For example, you say, no, I want to use the half moment of inertia. I don't want to use full moment of inertia of this section. You can make it I3 0.5. Will it make safe your design or unsafe? It will give you more factor of safety. Similarly, you say I want to use 90% of the area. I don't want to use the full area of beam. So it will give you safe design or not? Yes, it will give you safe. If you make this torsional constant very small, like 0.1, it means that now your beam cannot take torque. You understand? It means that you are designing your member for no torque. Okay? But if you make it 1, it means you have considered the torsional effect. And if you say max half or mass half, it will consider the half mass. If you say is the weight, you want the full mass but you want to reduce the weight, you can, these are the modifiers. For example, just like you have 1000 solid yarn in your pocket, but you say no, I have 9.9, I have 90% of it. Actually you have 1000, but you are reducing yourself that no, you have 900. Okay, these are just modification factors which you consider for any reason. Now you can add copy of property. You can change the size like 300. Now you can change the number of bars 3. You can also change the longitudinal bar like is number 19. Number 6 is number 19. Make it okay. So you can add as many sizes as you want, but I have not changed the name of this section. Okay. Now you have defined 4 sizes. Okay. You can define as many sizes as you want. For example, those who are doing senior design project, they know that they have to design like 10, 15 or 20, and sometimes if the building size is big, you have to define around 100 sizes for beam or maybe 100 sizes for column. But it is not recommended. A good design is that which is as simple as a piece of cake. I mean, all the columns in one floor same. All the beams at one floor same. Okay? Try to make a thing which is simple and easier. Because if you give too many sizes, maybe at the side, the people will be confused. Maybe they have provided this steel on this column and they have provided it on the other. I mean, human error is always there. For example, maybe he is talking to someone or he is smoking on the side and the bartender put the wrong steel over there. I mean, if you give the different sizes, but if you give the same sizes, it will be just like copy paste in his mind. Okay? So now you have defined two things. Number one, you have defined the material and you have defined the. So after this, don't forget to save it. Okay? If you don't save, and then it means what you have done will be gone. Okay, then now come down. Yes, load patterns. How many types of load we have in our building? And how many types of dead load we have? No, dead load. One is the self-weight, other load, surface finish load. You can add wall load if there are walls. Okay. For example, there are many types of dead load. Really? Okay, your luck. So, there are so many types of dead load, like surface finish load, like superimposed, and all these types of loads are known as superimposed dead load. Okay. So for all these superimposed dead load, the self-weight multiplier is 0. Self-weight multiplier is 0. Okay, I would recommend you to add dead load for self-weight separate and for all other loads separate. So you can easily differentiate. For example, now we have surface finish load. Okay, I will add this load as a dead. This is already there. So you can take surface finish, type dead and make it 0. Add new pattern. You understand? Oh, very difficult. Many of you are feeling sleepy. Anyhow, I don't have any other choice. I told you, I have to finish it. So self-weight surface finish is the one load, and if you have wall, you can also add the wall load here. And keep the self-weight multiplier as 0. Any other load, if you want, in surface finish, you can add surface finish load, you can also add the tie load. I mean, it's up to you how many dead loads you want to define, you can define it over here. When it means, 1 means that computer will automatically calculate it. Okay? For example, all of the dead load, there is no need to tell the dead load of the slab. When you calculate the dead load, you calculate the dead load of slab. You remember? Yes. So if you give it 1, it means you will just give the thickness and system will calculate the dead load itself. Similarly, the self-weight of beam, the self-weight of column.
So that's why we multiply them by 0, it will become 0, the volume.
No. if you give the wall thickness, okay, and you make it 0, it means that it will not consider the wall load, but it will consider the effect of wall. You understand? No.
So one means for the calculation.
For example, if you want that, no, I will not give the thickness of wall, I will directly apply the wall load, like 13 kilonewton per meter.
Yes.
You say I will apply the wall load 13 or 16 kilonewton per meter. So in that case, you will just give the value. Don't worry. I will show you how to check it. For the time being, you can trust on me, keep it 0. Okay, and when we will run the analysis, I will show you that this is your wall load. It is not 0. Okay? Okay, now live load. You can say LL and change the type live, and again it will automatically become 0 here, because you have to externally add. When you add any load externally, now you can just see here, self weight multiply. Now live load don't have self weight. Live load is the live load. Self weight is for the dead load, which is not going to be moved. For example, self weight of structure. Okay. Okay, add it. Now you want to add wind load. Okay, let's add wind load in one direction. Wind X, wind in X direction. Change wind N, but it is not finished here. Now for the wind load calculation, you must have to define according to what you want to calculate it. There are so many codes. UBC 97, BOCA, MDCC, BX, British Standard, AICE, from 88 to 95 to 02 to 05. I recommend you to use UBC 97 because in most of the buildings in Gulf region they are using UBC 97. Okay. When you click UBC 97, then you have to see modify lateral load pattern. What is this lateral load? Oh my God, what is this?
On the wall.
Exposure. Wind exposure parameters, wind speed, exposure type, importance factor. What are these things? These are the factors which you are not familiar. Okay, and all of these factors are according to UBC 97. Okay, I tell you what is exposure. There are 4 exposure categories: A, B, C, D. D is the worst, C is the second worst, B is the middle, and A maybe you not consider. B, C and D. B, for example, if your building is at cost, it will be D. Okay, let me show you UBC 97. Can I show you? Sorry. Okay. So these are the different codes which I have used in my job. Like for example, in Saudi Arabia you have Royal Commission of Jubail and Yahoo. Okay, and those are also included in Aramco specs. I'm just going to familiarize you with different types of, and these codes we have to use it. Okay, let me show you some document, some design document. You want to see? Are you interested to see a real design document?
Yes.
Actually, and crane data now. No. It should be here. I don't know where it is. Let me see some file in PDF because it will be easier for you. Okay, for example, this is a building. This is basically MUS is my name. Yes. So you give the design information like this. For example, how to give the, for example, in this building, most of the USA building and design codes have been followed. Okay. So what are the various codes? They are like, maybe you are not familiar, MDMA, AISC, AISI, and welding is according to this. And then these are the materials. For example, I told you that ASTM A grade 50. Maybe you would be saying, what are these? They are nothing. For example, built-up members, they are according to this grade. Okay, black cold form steel, it is according to this. Cables, rods, bolts, and these are the dead nodes. So we give information like this, that the building has like this much width. Actually, it is a part of some building, maybe. But what I want to tell you is that you must have to provide this information when you are going to design it. Let me find some more detailed one. Anyhow, this information is always there, what I am telling you. Now, why I opened the code? Because I wanted to show you the UBC 97. What is UBC 97? UBC. This is UBC 97. Okay. Now, if you, and this code gives you different values. For example, if you go to the table of contents and you go to the chapter 16 is for the loads, I remember. Where is chapter 16? Yes, structural design requirement. And Yes, chapter 16, you can see here. Chapter 16, Division 1. The chapter 16 gives you the different types of loads. For example, this is the, now please remember this, chapter 16. For example, this table gives you the live load. Now, many times I ask you that we take the live load from building code. Now please see here. For example, for office use, how much is the live load?
50 basic.